Have you ever hit enter on a Google search and just stopped for a second, amazed at the speed? It feels like actual magic, right? The answer is there before you can even blink. So how on earth does Google pull that off? Let's get into it.
Okay, so check this out. Let's take a kind of obscure search term like J2ME. In just 0.24 seconds, literally faster than a blink, Google rips through the internet and finds almost 9 million pages. But that's just one search from one person. Now multiply that by this number, 99,000. That's about how many searches Google is handling every single second. The scale here isn't just big, it's pretty much impossible to wrap your head around. Which brings us to the big question, the one we're all here for. How is it even possible to search billions and billions of pages, basically the entire digital universe, and get an answer back in the time it takes to snap your fingers? Well, here's the biggest secret, and it changes everything. The common myth is that when you hit search, Google frantically scours the entire live internet in that moment. But that's not what happens at all. The reality is, all the hard work was already done. When you search, you aren't searching the web. You're searching Google's own perfectly organized library of the web. So to really get a handle on this speed, we first have to understand how this incredible library even gets built in the first place. And it all really boils down to a two-step process. First, you have crawling, which is all about discovering what's out there. And then you have indexing, which is the massive job of organizing everything that's been found. So let's start with crawling. Just picture a massive army of little automated programs, people call them spiders, and their only job, 24/7, is to travel the web. They jump from link to link, page to page, constantly finding new stuff and checking for updates on old pages. They're like tireless librarians grabbing every book they can find. And all of that information they collect goes into one single place, the Google Indexed. This is the library. It is a gigantic database where every little piece of data is analyzed, sorted, and categorized. So don't think of it like a messy pile of websites. No, think of it like the most detailed card catalog you can possibly imagine for the whole internet. And when I say gigantic, I am not kidding. The Google Index is estimated to be over 100 million gigabytes in size. To put that into perspective, you could store a whole movie in 1 gigabyte. We are talking about a library on a scale that is just mind-blowing. Okay, so the library is built. Now for part 2. What happens in that split second after you type something in the search bar? How does Google navigate that massive library to find exactly what you're looking for? Now this is where it gets really clever. Google doesn't just match the words you type. It tries to figure out what you mean. It knows that change brightness is the same as adjust brightness. It can figure out your spelling mistakes. It knows that if you search for pictures of cats, you probably want to see, pictures, and that pizza near me is a request for a local map. And the magic behind this understanding is some seriously powerful AI. You might hear people throw around names like RankBrain or BERT. You don't need to know the technical details. Just know that these systems are trained to understand the messy, complicated way that we humans actually talk. They get what you mean, not just what you type. Okay, so Google gets your question, but that still doesn't totally explain the insane speed. To understand that, we have to go from the software to the actual hardware, the physical stuff that makes it all possible. So here's another huge secret to the speed, your search query. It's not sent to one single overworked computer that's trying to do everything by itself. No, instead, your question is blasted out to thousands of servers at the exact same time. Each server is only responsible for one tiny little piece of the index. It's the ultimate divide and conquer strategy. It's like having thousands of librarians all searching one shelf at the same time. This is a huge reason it's so fast. But there is one more hardware trick, and honestly, this might be the most important one. That massive index, it's not sitting on some old-school, slow-spinning hard drive. Instead, the most important parts of it are stored in RAM, random access memory. Think of it this way. RAM is like a computer's short-term memory, and a hard drive is its long-term memory. Getting something from RAM is like instantly recalling a thought. Getting it from a hard drive is like having to go to a file cabinet and dig it out. That one difference is what makes millisecond speeds even possible. So in a fraction of a second, the system has found millions of potential answers, but it can't show you all of them. So how does it decide which ones are the most helpful? Which ones get on that all-important first page? Well, that is the final step, ranking. To sort through all those results, Google's algorithms look at over 200 different factors or signals. They're asking hundreds of questions at once. Does this page actually match what the person was looking for? Is this a trustworthy source? Is the page a pain to use on a phone? And what about context, like where is the user and what have they searched for before?
And when it comes to figuring out quality, one of the most powerful signals has always been links. This was actually the original big idea behind Google. If a bunch of other really prominent expert websites all link to a single page, that's a huge signal. It's like a digital vote of confidence that says, hey, the information here is good and you can trust it.
And look, this isn't just Google's own PR. Independent analysis, like a study from The Economist, confirmed that the system really does work to reward reputable, high-quality information.
So, if there is one single thing to take away from all of this, it's this. The secret to Google's speed isn't really about searching faster. It's about organizing better. It's all about the decades of work that went into building the perfect library so that when you finally show up and ask a question, the answer is already there, just waiting for you. Which leaves us with a really fascinating question to think about. As search gets better and better and better at giving us exactly what we ask for, what happens to just stumbling upon things? What happens to the joy of discovering something amazing that you didn't even know you were looking for? It's a pretty deep question about how we find knowledge in the future.